Hi guys, welcome back to my channel. Today we are going to start IGCSE Physics paper 22, that is for May June 2015, paper code 0625. So let's begin. Question number 1 is figure 1.1 shows a distance time graph for a falling object. So there is a graph drawn where we have time on x-axis and distance on y-axis. Part A says that use this graph to find the time it takes for the object to fall from zero point 0.6 meter to 1.6 meter. So what we are going to do is we will mark these values on the graph and see what does it correspond on the x-axis. So for 0 0.6, if you just see this value and if I just extend 0 0.6 to the graph line, it gives me this value, which is approximately 0 0.38. So one value we got is 0 0.38, and then the next is 1.6 meters. So 1.6 is this line. So till here the graph line, and if we just extend it on the x-axis, so this is 0 0.62, 64 and 66. So the next we got is 0 0.6x. When you will subtract these two values, you'll get the time the object takes to fall down, and the subtraction of these two values will give you 0 0.28. And don't forget to put the unit. It's actually mentioned over here second, but sometimes when you're doing numericals, don't forget to put the units. Part B says, state and explain what the graph shows about the motion of the falling object. So if you see the graph, it is changing its speed because the gradient is changing. So we can say that the speed of the object is changing, or you can say that it is accelerating because the graph is a curve, which means that the gradient is changing. I have mentioned the compiled answer over here. I hope it was clear. If you have any doubts, you can mention in the comment box. Let's move on to the next question. So question number 2 says that figure shows an irregularly shaped piece of card. A student is asked to find the center of mass of the card. The student is provided with a clamp and stand, a small mass attached to a thin string and a long pin. Describe the procedure for finding the center of mass of the card. You may draw a diagram. So how do we find the center of mass? Basically, we will tie the string with mass on the pin in front of the card and hang the card on the pin from a hole, and make sure that the card can swing freely. Then you can place the plumb line or the pin, whatever is provided, and mark the line or position on the card in the direction of the plumb line. And then you can repeat the same process using at least one more hole, and where the lines cross, that is the center of mass of that irregular shaped object. Alright, so I have drawn the diagrams and mentioned the answer. So you will follow the same process. Then it says what simple test can be carried out to confirm the center of mass has been found. So technically the center of mass, that point which we are calling center of mass, the card will always balance at that point. And another thing you can do is that you can repeat the experiment from one new hole, and if the point of intersection is same, it means that the test you carried out is correct. Alright, so let's move on to question number 3. Question number 3 says a student has a beaker of liquid as shown in the figure 3.1. So we can see that this is the beaker and there is liquid inside. The student makes some measurements. His results are shown in the table. So mass of the beaker with liquid is 280 grams and mass of empty beaker is 120 gram. The volume of liquid is 200 centimeter cube. So the part one says that calculate the mass of the liquid, which is very easy. Obviously, the mass of a beaker with liquid is 280 and empty beaker is 120. So you will simply subtract them, 280 minus 120. If you'll do this, you will get the mass of the liquid. 280 minus 120 will give 160 grams. Okay, and alright, so part 2 is calculate the density of the liquid. For density, we know what is the formula, mass divided by volume. So mass we have calculated in this first part, which was 160. So 160 divided by the volume is given in the question, 200 divided by 200. So 160 divided by 200 will give you 0.8, and the unit mentioned is gram per centimeter cube. Let's move on to the next question. So the B part says that the student warms the beaker and the liquid on an electric heater as shown in the figure 3.2. So we are seeing there is an electric heater and the beaker. State the name of process by which thermal energy is transferred through the glass of the beaker. So what will be the thermal process over here? First of all, let's identify the medium. Here you can see that it is mentioned that the heat is being transferred, the thermal energy is being transferred through the glass, which is a solid. And for solid, what is the mode of transfer for thermal energy? Yes, that is conduction. So you will write conduction. Explain how thermal energy is transferred throughout the liquid by convection. So what happens that when the liquid gets thermal energy, or when the liquid is warm, it expands. Okay, when it expands, what happens that density of that warm liquid decreases and the less dense liquid will rise up. So this is how the convection current is set up, and the energy is transferred throughout the liquid. Alright, moving on to the next question. After heating for 20 minutes, the student reweighs the beaker and liquid. He finds that the mass of the beaker and the liquid has decreased to 260 grams. State the name of process that causes this decrease in mass. So the liquid is constantly being heated, and then after some times there is reduction in the weight. So it's quite clear that what will be the process by which it has decreased in mass, that is evaporation, or you can also call it boiling. Both will be correct. In terms of molecules, explain how this process occurs. So what happens that due to heat, the molecules, liquid molecules gain energy and they start moving faster. They're moving even faster than before, and what happens that they escape from the liquid into the air, and that is how there is the reduction in the weight of the liquid. That's the compiled answer. Moving on to the next question. Okay. So in this question, question number 4, it says that at a party, 3 balloons are filled with a gas less dense than the air. The balloons are tied to an empty drink can. The can floats without moving in the air above a table as shown in the figure. So question number 1 says that figure 4.2 represents the vertical forces acting on the can as it floats in the air. State the name given to the downward force labeled Y. So this force which is labeled Y and is acting downward, you have to tell the name of that force. And we know that when there is some downward force acting, that is the force of gravity, gravitational attraction, or you can also call it the weight of the body acting downward. So either you write weight or you write gravitational acceleration, gravitational attraction, both are fine. In terms of the vertical forces acting on the can, explain why the can does not rise or fall. So, if you see the forces, what is over here, x and y both are in opposite direction. Means the two forces are equal, but they are acting in opposite direction, which balances them. And when the two forces are equal and in opposite direction, they are balanced, means there is no resultant force. That is why the can does not rise or fall. Alright, so the part C says that a window is open, causing a draught of air into the room. The window is to the left of the balloon in can at the same height. Draw an arrow indicating the direction of the resultant force on the can. So over here you can see that they're saying that the window is on the left, and obviously the air is coming from this left side. So which direction will the can move? That is obviously the right direction. So you can draw this arrow over there. Part D, one of the balloons suddenly burst. State and explain what happens to the can. So now they're saying that the balloon has suddenly burst, and what will happen to the can? It can move downward, or it can fall, because what happens is that now the force y, it is greater than x, because over here first it was a balanced force. When this one of the balloon will burst, obviously x, the force x will become less than y, and hence the can will move in downward direction. All right, moving on to the next question. Alright, so question number 5 says that a footballer kicks a football and it bounces to another player. Figure 5.1 shows part of the path taken by the ball. So he has kicked the ball from here, and after bouncing several times, it reaches the next person. Use the words from the box to complete the sentences below. Each word may be used once, more than once, or not at all. So each time the football moves, it gains, the football moves dash, it gains gravitational potential energy. So if you recall the definition of gravitational potential energy, it is possessed by the objects which are above the surface of the earth, means they are at some height from earth. So if you see the word box, we can choose the word upward. Each time the football moves upward, it gains gravitational potential energy. And then each time the football hits the ground, it changes dash, and this results in energy stored as strain energy. So now over here recall the concept of strain energy. The strain energy is strain, basically it is the change of shape or size. So we can expect that each time the football hits the ground, it changes its shape. Okay. Each time the football, that's the B part, each time the football hits the ground, energy is transferred away from the ball. State how you can tell this from the diagram. So, if you see the diagram, every time they are saying that when the ball will hit the ground and bounce again, it will transfer its energy to the ground. Now, if you observe the bounces, the first bounce is bigger, then it is smaller, smaller, and then even smaller. So how we can tell this from diagram, that the energy is being released every time the height of the bounce is decreasing. So we can say that the energy is being transferred away from the ball. Second part says that state what happens to the energy that is transferred away from the ball. So it is transferred into the surroundings, that can be in the form of thermal energy, heat energy, or the internal energy of the surroundings. All right, moving on to the next question. Okay. Question number 6 shows a hydroelectric power station. There are some stages explaining how the power station works. They are not in the correct order. So they have given few options. You have to tell what is the correct order of the power station to work. Use the letters A, B, C, D to complete the flow chart below. Okay, so the first is rainwater flows off the hills into the reservoir behind the dam. After the rainwater flows, what happens is the water which comes down that goes to the pipes from the reservoirs to the turbine. Okay, so you will choose the option B over here. Once the water reaches the turbine, the falling water turns the turbine. So option D is more suitable. You can see that water will turn the turbine. The turbine transfers energy by a spinning shaft to a generator. After the energy is transferred to the generator, what happens is that inside the generator, the spinning shaft will turn the electromagnets. So you can see option C is more suitable. And then finally, what happens is the electromagnet turns inside a large coil, obviously, the option A. And when the coil is turned, electricity is generated. The part B, hydroelectric power is described as a renewable source of energy. Explain what is meant by the term renewable. So, renewable means which can be renewed. In simpler terms, the energy source that will never run out, that is known as renewable source of energy. The next part says that using a renewable source of energy is one advantage of hydroelectric power compared with energy sources. State two other advantages of hydroelectric power. So there are many advantages which we can state over here. So basically, the hydroelectric power is a low running cost setup, means it is cheap, you can say, and then it can be used as an energy store as well. It provides tourism also. Then you can say that it can be used as not used as you can say that it is less polluting. So you have to give any two, maybe you can use that it is cheap and then it causes no pollution, the simplest ones. Then state one disadvantage of the hydroelectric power. So although the setup is cheap, like the electricity produced by hydroelectric power is cheap, but the setup, the cost to make that setup is very high. Okay, so you can say that while setting up or the cost to build that hydroelectric power station is very high, and then it is limited, like it is only possible at few locations, it is not available everywhere. So the main disadvantage which we count is that it is costly to build the hydroelectric power station. Okay, moving on to the next question. Figure 7.1 shows a car and a snow tractor. The car and the snow tractor has the same weight. Explain why the snow tractor can travel across soft snow without sinking, but the car cannot. Okay, so the tractor tracks, they have larger area. Okay, you can see they cover the larger area with the ground, means they have maximum contact with the ground. But in case of car, it is not the same thing. And then pressure, or you can say that the weight of the car is spread over a larger area. That's why what happens is that it will not sink, but the car can. Okay, the part B says that the car driver checks his tire pressure in a warm garage. The pressure of the air inside the tire when it is warm is 24 Newton per centimeter square. The car is driven outside and left in the snow. Suggest a value for the pressure of the air inside the tire when it is cold. So the maximum it is given when it is warm is 24. So the pressure can be any value which is greater than 0 but less than 24. In terms of air molecules inside the tire, explain the change in pressure of the air. So what happens is that the molecules are slow. Slow molecules means they have less kinetic energy, and obviously there will be less force as well per unit area. So that is the reason why the pressure changes in air. All right, moving on to the next question. Okay, so over here we have a diagram which is showing two prisms and the critical angle is given. It says that visible light is one region of the electromagnetic spectrum. Uh, the regions are mentioned, sorry, the waves. Two regions of electromagnetic spectrum are missing. State the name of the missing region with the longer wavelength. So over here, two of them are missing, and out of that, you have to tell the one which has the longer wavelength. So for the longer one, we do have X rays as well. An infrared sensor is fitted into a room as a part of an intruder alarm system. Explain how the sensor detects a person in the room. So sensor detects the warm things or it can detect the changes in temperature. So when the person is warm or at different temperature than the surroundings, what will happen? The person will emit more infrared radiations into the surrounding and the sensor is able to detect that. The third part says that state two properties that are the same for all electromagnetic waves. So electromagnetic waves have same speed in the vacuum and they can travel in vacuum and they are the transverse wave. So they have same speed in the vacuum and they can travel in vacuum. Moving on to the next question. Okay. A student has two powerful bar magnets and an iron rod. The student uses the north pole of one magnet and south pole of the other. Starting from the center of the iron rod, he rubs the poles against the rod out to its ends. He repeats this many times. Figure 9.1 shows the student uses two magnets to make iron rod into a magnet. Part A says that label the magnetic poles created on the iron rod. So we know that the like poles will repel and unlike will attract. So obviously over here, when if it is the north pole, then this is going to be the south. And if this is south, then this is going to be the north pole. Describe how to test whether the iron rod has become a magnet or not. So what happens is it will repel a magnet or it will attract an unmagnetized iron or steel. So basically what you can do is you can bring it near to a magnet and obviously it will repel the magnet. Repel the magnet, obviously the like pole of the magnet. Suggest a material that could be used to make a permanent magnet. So steel is the best available option when it comes to make a permanent magnet. Describe how a permanent magnet can be demagnetized. So what you can do is you can place it inside the coil or you can heat it, and the coil is connected to the AC supply obviously, and when you provide it heat for a longer time and then cool it, the magnet will become demagnetized. All right, moving on to the next question. So another way of making a magnet is shown. State the name given to this type of magnet. So you see over here a battery is connected, and whenever you make a magnet through the AC supply, we call that electromagnet. A magnet made due to electricity. Suggest an advantage of this type of magnet. So when you have an electromagnet, its magnetism can be controlled. That is the biggest advantage. Magnetism can be controlled. Suggest one use for this type of magnet. So it can be used in the cranes for moving the vehicles, or it can be used in the relays or electric bells. Anywhere you can use relays, electric bells, or the cranes. Next, we have figure 10.1 shows a charger for a mobile phone. The charger contains a transformer, suggests a suitable material for the coils of the transformer. So the best material for the coils of transformer is copper. The transformer has an input voltage of 240 volts and an output voltage of 6 volt. There are 6000 turns on the input coil. Calculate the number of turns on the output coil. So over here 240 volt is your primary voltage, and then 6 volt will be your secondary voltage, and then 6000 turns are basically the primary turns. You have to find the number of turns on the output coil. So the formula we will be using is Vp over Vs equals Np over Ns. So putting the values over here, you will get the answer as 150. Place a tick in the box alongside the condition in which it could be dangerous to use the charger. So cool, damp, dry, and warm. When it is damp or wet conditions, then it is dangerous to use the electric equipment. So you'll tick damp. Okay, question number 11. In some areas, there are high levels of background radiation. Explain what is meant by the term background radiation. So, background radiation are basically the ionizing radiations, or you can call them radioactive emissions from the surrounding that is always present in the surrounding. The next question is suggest how background radiation can be detected. So one of the famous background radiation detector, we all know the name of that. What is that? Geiger-Muller counter, or we call it GM tube as well. Radon 219 is a radioactive gas. Complete the table below to show the number of each type of particle in a neutral atom of radon. So the electrons present in the radon will be 86. We know that this is the electron number. And then neutrons will be 133. And the proton number will be 86 again. Alright, if you're confused about how I got the neutron number, so basically that is 219 minus 86, that will give you neutron number. Alpha particles are emitted when radon 219 decays. Okay, tick the box alongside the correct symbol for an alpha particle. So what is the symbol for alpha particle? We know it is this one. For what part of the radon 219 atom is the alpha particle emitted? So that is nucleus. Okay, complete the table below to show the composition of an alpha particle. So what is the composition of alpha particle that you have to tell? Over there, the electrons, they are basically 0 electrons in an alpha particle, 2 neutrons and 2 protons. You have to remember this combination. Moving to the next, which is probably the last question of the paper. Figure 12, question 12. A student sets up the circuit shown in the figure. On figure 12.1, label the thermistor with a T. So what is a thermistor over here? You have to tell that. This one is the thermistor. The student wants to determine the resistance of the thermistor at different temperatures. Complete the sentences below. The meter to be connected in series with the thermistor is, we know that what is connected in series, that is ammeter. And the meter to be connected in parallel is voltmeter, obviously. These are the students' result for the temperature of 20 degree. Calculate the resistance. So the formula for resistance is voltage divided by current, which is 3.2 divided by this value 0.0050, and this will give you 640 ohms. When the temperature increases, the resistance of the thermistor decreases. State what happens, if anything, to the current in the thermistor. So whenever the temperature increases, the current value will also increase. That's it from the paper 2022. And if you have any questions, you can mention in the comment box. If you want some specific paper to be done, you can mention that as well. All right, bye bye, take care.